Hey, welcome to the second video in our series on trigonometry for electricians. In this video, we're start getting into trig functions, sine, cosine, and tangent. But before we do that, what we have to do is name the sides of the triangle. We have this side here, which we discussed in the last one, is always going to be called the hypotenuse. But this fella and this fella, they have different names. Now, it's all going to be based off what we call our designate angle. Now, you see this little funky Greek symbol here? We call that theta. And in this case, this is my designate angle. So let's walk through how I name these sides based off the fact that this here is my designate angle. We know that this is the hypotenuse. There we go. Now we have our designate angle sitting here, and we have our side over here, which is sitting opposite of that. Guess what that side is called? Yep, that's right. That's our opposite side. Now we also have this side that's sitting down here that is sitting adjacent to the theta symbol or the designate angle. And you notice I said adjacent. So guess what that name is going to be? Yep, you guessed it, adjacent. Now that's all based on the fact that this theta or this designate angle is sitting here. Now what if we moved it up to this side here? Would that change things? 100% yes. Now the hypotenuse is always going to be the hypotenuse because it's the longest side, so that didn't change. But this side and this side are going to change names. Let's move that theta up to here. Our designate angle is now up top, which means that this stays the hypotenuse. Now here comes the changes. Now this side, which used to be the adjacent, is now the side that is opposite our theta or our designate angle. And this side over here, which once sat opposite our designate angle, is now sitting adjacent to our designate angle. Now when we start dealing with these things, we're going to talk about the ratios of the sides of the triangle and how they're related to our designate angle. They all have ratios. Each side here has a ratio which will help us determine what this angle is. So let's flip this triangle back onto its side here and make this our designate angle and talk about these ratios. Now on this side, I've got my designate angle. This will be my opposite. This is my hypotenuse, and this is my adjacent. If I want to figure out what this angle is, somebody who's smarter than all of us has determined that the sine of this angle is equal to the ratio of my opposite side over my hypotenuse. Now that's not where it ends. There's others. We also could say that the cos of this angle, or the cosine of this angle, is equal to our adjacent over our hypotenuse. Say that 5 times real fast. The ratio of this side over this side. That is our cosine. We've got one more. We can say that the tangent of our designate angle, or the tangent of theta, is equal to our opposite over our hypotenuse. And those are the three trig functions we're going to use. We're going to use sine, cosine, and tangent. And there's an easy way to remember the ratios. Instead of having to have this hard memorization problem, we can just come up with this mnemonic, and it is this. I'm sure a lot of you guys know it. So, ka, toa. So, sine is opposite over hypotenuse. Ka, cosine is adjacent over hypotenuse. And toa, tangent, is opposite over adjacent. Now you should never forget that. I'm sure you actually already knew that coming into this. Now, as we did in the previous video, let's start throwing some numbers at this and playing with this and figuring out how we can determine angles. So let's use the common 3, 4, 5 triangle here. You can use Pythagorean theorem to determine that 3 squared plus 4 squared equals 5 squared. It all plays out from the last video. You can prove that. Now what we're trying to do is determine what this angle is, because that becomes very important to us in electrical theory later on. Now we can use any of those three trig functions, sine, cosine, or tangent. So what we're going to do is walk through with all three. Let's start out with sine. The sine of this angle is equal to our opposite over our hypotenuse. So sine theta is equal to 4 over 5. So let's just write that off on the side there. The sine of theta is equal to 4 over 5. Now let's get rid of that 4 over 5 and turn that into a number we can deal with. The sine of theta is equal to 4 divided by 5, which is 0.8. So now comes the tricky part. We've got sine of theta is equal to 0.8, but we don't want that sign there. We want to get rid of that. We want just to figure out what the theta is or what the angle is. So what we're going to have to do is use our calculators, and if you take a look at your calculator, you should have trigonometry functions on your calculator. If you don't, then you've got the wrong calculator on you. And if you have a smartphone, you can probably just take your calculator out, and if you lay it on its side, it should pull up some trig functions. But let me show you a picture of the calculator that I use when I'm teaching this stuff. So what we need to do is find your inverse sine. Now if you look at this calculator here, I've got my trig functions up here, sine, cosine, and tangent. I've got sine right there. Now if you notice up above there, I've got sine to the -1. That's your inverse sine. Now I've got this second function. You see it's been worn out because I use it quite a lot. That's like your shift key. So you press second function, inverse sine 0.8, or depending on what your calculator is, it might be 0.8, second function, inverse sine. Every calculator is different, so you'll have to get used to it on your own. But that should get you the answer that you're looking for. That will get rid of the sine. So inverse sine 0.8 will give you the angle, which is 53.1 degrees. So there you go. We've solved the angle. We have solved theta using sine, which is our opposite over our hypotenuse. Now we're going to use the other functions as well. We're going to use cosine and we're going to use tangent, and hopefully this angle should work out the same using different ratios. So let's take a look. Using cosine of theta, same idea. All we have to do is take 3 divided by 5 because cos is adjacent over hypotenuse. So we take 3 divided by 5 and that equals 0.6. So the cos of theta is equal to 0.6. And again, using our calculator, we want to get rid of the cos. So we're going to inverse cos that. Let's take a look at that one. So just as we had before, we're just going to take the second function and we're going to use cos. So it'll be the second function, which gets you that inverse cos. So again, we'll point in 0.6, second function, inverse cos to get our answer, or perhaps depending on your calculator, it's inverse cos 0.6. Anyway you look at it, we're going to get an angle of 53.1 degrees. So we have determined using sine that we can get 53.1 degrees. We've now used cosine. That leaves us with tangent. Let's take a peek at that one. Using tangent, we use the formula TOA. Tangent of theta is equal to 4 over 3, opposite over adjacent. So the tangent of theta, let's turn that into a number, is going to equal 1.33. And again, we want to get rid of the tan, so we have to inverse tan that out of there. So let's take a look at our calculator one last time. So let's take our button here and press inverse tan 1.33 equals, which is that guy, or you're going to put 1.33 inverse tan, again depending totally on your calculator, and you should get your angle, which we're hoping is going to be 53.1 degrees, aren't we? Let's take a look. Well, what do you know? It is 53.1 degrees. So there you go. We have determined using any of these three sides, using either sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, or tangent, which is opposite over adjacent. Using those fun trig functions, we can use it to determine the angle. And that's what we're doing with this one. Now what we're going to do in next video is determine what to do when you've got just an angle and a side. How do we work that out? Hopefully this was helpful. If you have any questions at all, please leave a comment in the comment section, and we'll see you in the next one.